weather event, big disaster somewhere, reporters call scientists like me and say, what does this have to do with climate change? And so that's my topic today. So let's start with what we do know, which is that the climate is getting warmer. This is a graph from the most recent report of the Intergovernmental Panel on Climate Change, IPCC, showing the surface temperature of the Earth, average surface temperature of the Earth expressed as departures from its historical average in degrees centigrade, starting at about 1850 to when the report came out, which was a few years ago. And it's, in the recent, most last century, you see it going up. There's a flat period in the middle of the century, but that keeps going up, and it was flattish for a few years, and then more recently we're up here. So it's getting warmer. These are the averages decade by decade. You can see that the little fluctuations don't really add up to much when you look over this long time period, except for this period here. Each decade is warmer than the one before. So we know that, and we know mostly why. We believe that the majority of this warming over the 20th and now early 21st century is due to human activity, especially emissions of greenhouse gases. This warming is due to human emissions of greenhouse gases, carbon dioxide especially, but also methane, nitrous oxide, and others. So what's shown here is the projections for the future. So this is the surface temperature record up to the present, with some uncertainty around it. But then these are climate model projections that take it from all the world's best climate models. And these are two scenarios. So this is a scenario where we reduce emissions sharply by being more energy efficient and investing in renewable energy and all that stuff. So we burn less fossil fuels. The warming could stabilize below 2 degrees centigrade. This big range here is uncertainty due to the different climate models, which give different estimates of how much warming you get for a given amount of greenhouse gases. And this is a trajectory where we don't do much of that, and we just keep burning fossil fuels more and more, which is closer to the trajectory that we're actually on. And in that case, we warm somewhere between 3 and 5 degrees centigrade by the end of the century. You about double that to get the Fahrenheit number. These are just different scenarios showing different amounts of warming. This is the different amounts of carbon emissions, I should say. This is the most carbon emissions, and then these are other scenarios depending on what we do. So we're getting warmer due to greenhouse gases. We know that, and it's going to continue. Even if we were to be very aggressive, we still get some more warming, and more likely we'll see more than that. Let's see. Okay, so I'm talking about what we know and what we don't know. So I'm going to get to extreme weather in a minute, but before we do that, I'm going to talk about some of the physical manifestations of climate change, because it turns out that the different types of extreme weather events respond differently, and what we know better is when we can connect the extreme weather event to some feature of climate change that we understand very well. And when the extreme weather event is connected more distantly to the things we know well, then we know less. And so the thing we know the most about is what I just said, that the temperature is getting warmer. But there's some other things that follow pretty directly from that, and one of them is water vapor. So this is a graph showing, and this is now historical observations. This is not model projection. So this is a graph showing specific humidity at the surface of the Earth, averaged over the surface of the Earth from the late 1970s up until recently. The more recent years would be up here. This is from satellite data, that's why it doesn't go back very far. Satellite data is involved in this. But you see specific humidity increasing. It more or less tracks with the temperature. And I think I actually won't explain this one. This is a more complicated graph that shows the same thing. But the main thing is that it's basic physics that the amount of water that can be in the vapor phase in the air is strongly controlled by the temperature. The warmer it is, the more water vapor you can have. And so if the climate gets warmer, you can have more water vapor in the air, and we're quite confident that we do have more water vapor in the air as the climate gets warmer. It's a the physics connecting water vapor to temperature is very solid. So such that anything that's a direct consequence of that water vapor increase is something that we'll understand pretty well. Are strongly related to how much water vapor is in the air. We'll get to that in a minute. But then there are other things. What's the trick? Okay, another consequence of warming that's quite certain in its overall direction, although not in magnitude, is sea level rise. So this is the global average sea level change from the beginning of the previous century in millimeters here. So the sea level's been rising for the last 100 years, 100 plus years, at a rate, the recent rate is a little over 3 millimeters per year. 3 millimeters is like the white part of my fingernail. So it's slow, but it keeps going. And I'll show a graph at the end of what the predictions are, but it's quite likely that this will accelerate, that sea level will rise more. The rate at which sea level will rise in the coming century is uncertain. We don't know how, whether it'll rise a foot by the end of the century or 3 feet by the end of the century. Some people even think 6 is not impossible. So there's a lot of uncertainty about the magnitude, but the direction is quite certain. So anything that any extreme weather event that's strongly dependent on sea level, we know the direction that's going to go to. The reason sea level rises is mainly, there's 2 reasons. One is the water that's already in the ocean swells up as it warms, just like most types of matter swell up as they warm. And that accounts for the majority of the sea level rise to date. But the other thing that happens is that when ice melts, the ice that's on land, and the big chunks of ice on land are Greenland and Antarctica. When those melt, the water runs into the sea, and that raises the sea level. And in the future, that's likely to be the dominant source of sea level rise. And the uncertainty comes about because we don't know how quickly Greenland and Antarctica will lose their ice. It's not just a matter of melting; it's a matter of how the glaciers slide around and break. But we know the direction they're going. They're not getting bigger; they're getting smaller. Sea ice, by the way, is melting like crazy, but that doesn't affect the sea level at all because the sea ice is already floating. So although sea ice melting is important for other reasons, but it doesn't affect sea level. But then there are other things that we really don't know very well. So this is a prediction from 10 different climate models showing